very shocking, so to speak, a name. I'm not going to talk about it just yet. So it's integration. You may know something about it or not, so forget about it for a moment. So in section 4.1, we're going to talk about something called antiderivative. And what does antiderivative mean? You're going to find out in a few minutes. So let's suppose we are given a derivative function. I'm sneezing, sorry. So let's suppose we are given a derivative function. Now let's say we are told that f prime equals 3x squared plus x minus 2. And let's suppose that we are asked now, given this derivative, we're asked to find all possible functions f of x whose derivative is given above. Okay, so whatever function I get, when I differentiate it, I have to get this function. And it says all, so we're going to talk about it in a moment. Okay, so how do I determine the antiderivative? The function that I differentiate to get, so for now, let's take it piece by piece. So how do I get the function that I differentiate to get 3x squared? Well, 3 has to stay. And I will have to multiply it by x to the third divided by 3. How did I come up with this? I increased the power, the existing power, by 1, and I divided by the result, by that number. Okay, I have to show that the derivative of this is that 3 stays in place, or you can simplify it, it doesn't matter. When I differentiate x cubed, I get 3x squared. Bring down the power, subtract 1 from the power, and I get back 3x squared. So when I want to differentiate x to the nth plus 1 over n plus 1, I bring down n plus 1, I simplify n plus 1 with n plus 1, and I subtract 1 from the power. And this is the procedure we just applied here. I increase the power by 1, and I divide it by the result. Okay, moving on. Plus, which function prime will be x? In the same way, I increase the power by 1, and I divide by the result. When I differentiate this, do I get that? Yes. I bring down 2, simplify 2, subtract 1 from the power, and I get x. Can anyone help with a function whose derivative is -2? Which function I differentiate to get -2? Anyone, please?
-2.
-2 prime will be 0. So this is not 0.
Is it x to the power of 1?
Exactly. So when we, thank you so much. When we differentiate -2x, we get -2. Now careful. All plus a constant c. How come? If C is 0, I get the same answer. If C is 5, I get the same answer. If C is 1500, I get the same answer. If C is negative 500, I get the same answer. So this is all. And they're all different functions. Yes, I'm going to simplify 3 with 3. So the answer is f of x equals x to the third plus x squared over 2 minus 2x plus c. This is the whole thing is the most general antiderivative of the original function, a derivative 3x squared plus x minus 2. This is a family. You can either say the most general antiderivative, or you can say it's a family of functions, infinitely many, because c can be any real number. So we have infinitely many functions whose derivative is this. So notice that we are going backwards, so to speak. We are given a function, and we are trying to determine which function has this derivative. In the past, up until now, we were given a function, we were asked to find the derivative. Now we're given the derivative, and we're asked to find either the most general antiderivative or a specific antiderivative. So we may be asked to find exactly one, given some restriction, some condition, some initial value, and we will determine the c, and that will be a unique function. In this particular example, we were asked to find the most general antiderivative, meaning all family, all functions, the entire family of functions whose derivative is this. Any questions on this explanation so far?
Quick question, Lucy.
Yes, please, anything.
So when I see that you did 3 times x cubed over 3, like let's say the x squared had a number as well, would you also multiply it?
As long as when I differentiate this, I get the original given piece. Yep, of course. Yep.
Okay, thank you.
Yep. So as long as the derivative of this is that, as long as the derivative of this is this, and as long as the derivative of this is 0, and as long as the derivative of this is that, everything is clear. Very good question. Okay. I would like to open the book and practice a little bit with different problems. I have it practiced. Okay, I'm here. Please don't be shy, ask any question. Okay, so as you see, in this particular set of problems, we're going to go to the other side, not yet, today, but not at this moment. So we are asked to find f. We are given, as you see, only derivatives, but we are specified here on the side an initial value. We are told, find f given the derivative, but also knowing that f of 0 is 6, or f of 0 is 1/2, or f of 1 is -5, and so on and so forth. So in this case, we are not asked to find the most general antiderivative, all functions that have this derivative. No, we are specified, find that one that has also, or that fulfills the given restriction. Would you like to choose anything from 47 to 56, or I will?
Can we do 52?
Yes. Let's copy 52. What does 52 say? Perfect. So in 52, on page 392, we are given f prime of x, 6x squared minus 4x and plus 2. And we're specified that f of 1 is 9. Okay, perfect. So first we're going to start by finding the antiderivative. 6 stays, x squared, increase the power by 1, and divide by the result. Copy 4, increase the power by 1, divide by the power, and then 2x, and plus a constant c. The derivative of this is guaranteed to be that. The derivative of this is guaranteed to be that. The derivative of this is guaranteed to be that. And the derivative of this has to be 0. And it is. I will clean it up. So I have f of x equals 2x cubed minus 2x squared plus 2x plus c. This is the most general antiderivative of the given derivative, of the given function. It's a function. It's a derivative, but also a function. But we are specified f of 1 equals 9. Why do you think this condition is here? What am I going to do with this? Any suggestions, please? Why is this given to us?
Plug 1 into 9.
Of course, plug
Sorry,
1 into
x.
the function and set it equal to 9 in order to find the constant. This is also called the constant of integration, but we're going to talk about integration in a minute. Okay, so when I plug in 1, I have 2 minus 2 plus 2 plus c, and I am told that f of 1 is 9, so I have to set this equal to 9. These two go away. 2 subtract from 9, c must be 7. So from finding first the most general antiderivative of this function, with a given condition, I determined one function. Which function? This one. This is the only function whose derivative is this, and also fulfills the given condition that f of 1 is 9. So we were specified the condition to help us find c, the constant c. Any questions on this? Do you think we need other examples, or are we okay with this?
Can we try one more?
Yes, of course. I'm waiting for you to choose. I like to choose something like 53, but it's up to you. Or if I get to choose, I will choose 53.
53 what?
Okay, so let's copy 53 and let's discuss it. This is page 3 and this is 53. This is a very important example, and you'll see in a minute why. F prime of x equals 5 e to 2x, and we are told that f of 0 is 1/2. So let me refresh your memory on something. When we differentiate e to the x, we get e to the x. Now when we differentiate e, let's say, to kx, any constant, k constant, well, it's e to a function now, not x, a function. It's e to a function prime is e to that function times the inner function prime. So this is k e to kx. Remember, we're going backwards now. So from here, in order to find the antiderivative, I have to remember this piece. Okay? So e to 2x divided by 2 plus a constant c. So when I differentiate this piece, for this, of course, c prime is 0. So when I differentiate this, I have to get that. If I don't, this is wrong. So 5 and 2, that's fine. When I differentiate e to 2x, I get e to 2x times 2. That simplifies with the 2 in the denominator, and that's how I get that. So careful here. when I differentiate the k's in front. When I find the antiderivative, the k is in the denominator. So please be very mindful of this. It's very important. Okay, now we are told that f of 0 is 1/2. This condition will help us figure out c. That's why it's there. Okay, so f of 0, e to 0 is not 0, careful, e to 0 is 1. So I have 5/2 plus c equals the y value, which is 1/2. So 1/2 minus 5/2 is -4/2, so this is c equals -2. So I found the specific antiderivative, which is f of x, 5/2 e to 2x minus 2. This is the only function whose derivative is this and goes through this point. Or in other words, when x is 0, y is 1/2. This is a unique antiderivative. It's not a family of functions. This is a family of functions, all of them having the same derivative. This is the most general antiderivative. But once we have a condition, we no longer determine the most general antiderivative. We are specified one, a unique antiderivative. Any questions?
Let's say it wasn't 2x, but maybe 8x would be
Yes.
over 8.
Exactly.
Okay.
Yes, because e to 8x divided by 8, when you differentiate it, you have e to 8x multiplied by the inner function front divided by 8, and that's how you get this. So, thank you. So when we differentiate the k's in front, when we integrate the k's in the denominator. And you can always say, that's what the beauty of the antiderivative, I don't need anybody's help to tell me whether this is wrong or correct, either one. When I differentiate, I have to get that. If when I differentiate, I don't get that, I know it's wrong. This will not always be possible. You'll see when and how shortly. Okay, any questions? Okay, one more example that I would like, with your permission, to make up. So let's suppose I have a derivative that has 1 over x minus x to -3 plus 2x. This time I'm asked to find the most general antiderivative, no condition. Okay. Which function prime is 1 over x? This is very easy. Minus. I add 1 to the power, and I divide by the same number, the result. Plus, this is easy. I add 1 to the power, and I divide by the result. And of course, plus a constant c, because I'm asked to find the most general antiderivative. But I need to discuss this. When I differentiate this, I get 1 over x. Anyone remembers?
It's an LR.
Thank you very much. Natural log of the absolute value of x. I waited till this moment to talk about this absolute value inside natural log. So if you remember, the absolute value can be two things. If x is a positive number, there is no need of the absolute value. But if x is negative, the absolute value will still be positive. But in order to simplify it without the absolute value symbol, we will write negative x for x less than 0. And this is a formal definition of the absolute value. Formal definition of absolute value. You can say, but what's with this negative? Yeah, when x is negative, with negative in front, this will also be positive. Why do we need to even specify these two things? Because most of the time, we cannot work with this. This is a complicated situation. It has two different options. So every time we see this, we normally change it into what it equals to. Either positive x or negative x. If positive x when x is positive, but negative x when x is negative, because the result has to be positive at all times. Okay, now let's take a look at the natural log of the absolute value of x. So because absolute value of x has two options, natural log of the absolute value will have two options. The natural log of x and the natural log of negative x. One caution, I can no longer have the equals equal to 0 here because it's natural log. Natural log of 0 does not exist. So I have to exclude the 0 and just say positive and just say negative strictly. Now let's differentiate. I want to find the natural log of the absolute value prime. Fine, no worries. Very easy. Natural log of x prime is 1 over x. Let's think here. Natural log of a function is 1 over that function times the inner function prime. But this is the same thing with 1 over x. So, when we find the antiderivative of 1 over x, we have to write the natural log of the absolute value of x. Because of this reason, if I have positive x or negative x, the result of the derivative is the same. When I differentiate this, I get 1 over x. When I differentiate this, I also get 1 over x. So please remember, when we're asked to find the antiderivative of 1 over x, we have to write natural log of the absolute value of x. Any questions?